I'm going to read my notes that I took on Chapter 3 of the 11th edition of How to Think Straight About Psychology by Keith Stanovich. These notes are just meant to be a potential helpful study guide for people who are reading the book. They're not a substitute for actually reading the book, and most of these notes are taken directly from the sections that I thought were most important. Chapter 3. Operationism and Essentialism. But doctor, what does it really mean? And I'm going to read the Chapter 3 summary, which is actually at the end of the chapter, but I like to read it first before I read the notes from the other sections of the chapter. So, Chapter 3 summary. Operational definitions are definitions of concepts stated in terms of observable operations that can be measured. One of the main ways that we ensure that theories are falsifiable is by making certain that the key concepts in theories have operational definitions stated in terms of well-replicated behavioral observations. Operationally defined concepts make scientific knowledge publicly verifiable. Such definitions are in the public domain so that the theoretical concepts that they define are testable by all, unlike intuitive, non-empirical definitions that are the special possession of particular individuals and not open to testing by everyone. Because psychology employs terms from common discourse, such as intelligence and anxiety, and because many people have pre-existing notions about what these terms mean, the necessity of operationally defining these terms is often not recognized. Psychology is like all other sciences in requiring operational definitions of its terms. However, people often demand answers to essentialist questions about the absolute underlying nature of a concept of psychology that they do not demand of other sciences. No science provides such answers to ultimate questions. Instead, psychology, like other sciences, seeks continually to refine its operational definitions so that the concepts and theories more accurately reflect the way the world actually is. The section before 3.1 starts. The definition of essentialism. Essentialism is the idea that the only good scientific theories are those that give ultimate explanations of phenomena in terms of their underlying essence or their essential properties. Karl Popper came up with the term essentialism. Science does not answer essentialist questions. Instead, science advances by developing operational definitions of concepts. Section 3.1. Why scientists are not essentialists. Scientists do not claim to acquire the type of knowledge essentialists seek. Here are some essentialist questions about gravity. Do physicists really know what gravity is? What is the real meaning of the term gravity? What is the underlying essence of gravity? What does it ultimately mean to speak of gravity? The above questions about gravity are essentialist questions, and they are not addressed by scientists. Science advances by developing operational definitions of concepts. A common indication of the essentialist attitude is an obsessive concern about defining the meaning of terms and concepts before the search for knowledge about them begins. But we must define our terms is a frequent essentialist slogan. What does that theoretical concept really mean? The idea seems to be that, before a word can be used as a concept in a theory, we must have a complete and unambiguous understanding of all the underlying language problems involved in its usage. In fact, this is exactly the opposite of the way scientists work. Before they begin to investigate the physical world, physicists do not engage in debates about how to use the word energy or whether the word particle really captures the essence of what we mean when we talk about the fundamental constituents of matter. The meaning of a concept in science is determined after extensive investigation of the phenomena the term relates to, not before such an investigation. The refinement of conceptual terms comes from the interplay of data and theory that is inherent in the scientific process, not from debates on language usage. Essentialism leads us into endless arguments about words. Instead, scientists believe that such language games distract us from matters of substance. For example, concerning the question, what is the true meaning of the word life, two biologists give the startling answer that there is no true meaning. There is a usage that serves the purposes of working biologists well enough, and it is not the subject of altercation or dispute. In short, the explanation of phenomena, not the analysis of language, is the goal of a scientist. Although there are different forms of operationism, it is most useful for the consumer of scientific information to think of it in the most general way. Operationism is simply the idea that concepts and scientific theories must in some way be grounded in or linked to observable events that can be measured. Linking the concept to an observable event makes the concept public. The operational definition removes the concept from the feelings and intuitions of a particular individual and allows it to be tested by anyone who can carry out the measurable operations. Similarly, psychologists cannot be content with a definition of anxiety, for example, as, quote, that uncomfortable tense feeling that I get at times, end quote, but must define the concept by a number of operations such as questionnaires and physiological measurements. A concept in science is defined by a set of operations, not just by a single behavioral event or task. Educational psychologists define a concept such as reading ability in terms of performance on a standardized instrument such as the Woodcock Reading Mastery Test, Woodcock 2011, that contains a whole set of tasks. The total reading ability score on the Woodcock Reading Mastery instrument comprises indicators of performance on a number of different subtests that test slightly different skills. For example, reading a passage and thinking of an appropriate word to fill in a blank in the passage, coming up with a synonym for a word, pronouncing a difficult word correctly in isolation, and several others. Collectively, performance on all these tasks defines the concept reading ability. Imagine trying to define operationally something as seemingly conceptually simple as typing ability. Imagine you need to do this because you want to compare two different methods of teaching typing. Think of all the decisions you would have to make. You would want to measure typing speed, of course, but how long a passage? A passage of only 100 words would seem too short, and a passage of 10,000 words would seem too long. But exactly how long then? How long does speed have to be sustained to match how we best conceive of the theoretical construct of typing ability? And what kind of material has to be typed? Should it include numbers and formulas and odd spacing? And how are we going to deal with errors? It seems that both time and errors should come into play when measuring typing ability. But exactly what should the formula be that brings the two together? Do we want speed and errors to be equally weighted, or is one somewhat more important than the other? The need for an operational definition would force you to think carefully about all of these things. It would make you think very thoroughly about how to conceptualize typing ability. The Houston Rockets at the National Basketball Association tried to develop better methods of measuring a player's performance than had been used before. For example, rather than just measuring the number of rebounds a player got, they measured the numbers of rebounds divided by the number of opportunities for the rebound. That is, they measured the proportion of successful rebounds. They moved all their statistics, which were points, steals, rebounds, etc., from a per-game basis to a per-minute played basis. What the Rockets were essentially trying to do was to develop better, more refined, operational definitions of player impact than had been used before. Their efforts demonstrate that better operational definitions are often more specific. Consider the task of the Food and Drug Administration, which has to decide what is an acceptable level of contamination for various foods as opposed to what are considered unavoidable defects. A federal agency such as the FDA cannot be subjective about such things. It needs strict operational definitions of its judgments with respect to contaminants in each food that it inspects. So, for example, it comes up with operational definitions of the following sort. An unacceptable level of contamination in tomato juice is more than 10 fly eggs per 100 grams. An unacceptable level of contamination in mushrooms is 5 or more maggots 2 millimeters or longer per 100 grams. Very gross, but commendably operational. Operationalizing a concept in science involves measurement, assigning a number to an observation via some rule. A non-mathematician rarely cares about the properties of numbers when they are used merely as abstract symbols. We don't care about the number 5 by itself, but as soon as the number 5 becomes 5 pounds or $5 or 5% inflation or 5 IQ points, then suddenly we start to care. For an operational definition of a concept to be useful, it must display both reliability and validity. Definition of reliability. Reliability refers to the consistency of a measuring instrument. Whether you would arrive at the same measurement if you assessed the same concept multiple times. If the measure of a concept yields similar numbers for multiple measurements of the same concept, we say that the measuring device displays high reliability. If we measured the same person's intelligence with different forms of the same IQ test on Monday, Wednesday, and Friday of the same week and got scores of 110, 109, and 110, we would say that the particular IQ test seems to be very reliable. By contrast, if the three scores were 89, 130, and 105, we would say that that particular IQ test does not seem to display high reliability. There are specific statistical techniques for assessing the reliability of different types of measuring instruments, and these are discussed in all standard introductory methodology textbooks. Reliability is only about consistency and nothing else. Reliability alone is not enough for an operational definition to be adequate. Construct validity. Construct validity refers to whether a measuring instrument, operational definition, is measuring what it is supposed to be measuring. An example of reliability versus validity. An examiner does a test of intelligence by attaching a device to a subject's foot. This method would give the same results every time you used it, so it would have extremely high reliability. The test would not actually be reflective of the subject's intelligence, though, so it would have no validity at all. The link between concepts and observable operations varies greatly in its degree of directness or indirectness. Few scientific concepts are defined almost entirely by observable operations in the real world. Most concepts are defined more indirectly. The use of some concepts is determined by both a set of operations and the particular concept's relationship to other theoretical constructs. There are concepts that are not directly defined by observable operations, but are linked to other concepts that are. These are sometimes called latent constructs, and they are common in psychology. The type A behavior pattern is a good example of a concept that is a latent construct. Type A behavior pattern is a concept defined by subordinate concepts, which are a strong desire to compete, a potential for hostility, time-urgent behavior, an intense drive to accomplish goals, anger, and several others. Each subordinate concept requires an operational definition, and each does have an operational definition. So, the type A behavior pattern is a concept that is not directly defined by operations, which is synonymous with operationally defined. Instead, the type A behavior is a concept that is defined by a series of other concepts, each of which have been operationally defined. It is important to realize that the definition of a scientific concept is not fixed, but constantly changing as the observations that apply to the concept are enriched. If the original operational definition of a concept turns out to be theoretically unfruitful, it will be abandoned in favor of an alternative set of defining operations. The concepts and theories of human memory have likewise evolved. Psychologists now rarely use global concepts like remembering or forgetting. Instead, they test the properties of more specifically defined memory subprocesses, such as short-term acoustic memory, iconic storage, semantic memory, and episodic memory. The older concepts of remembering and forgetting have been elaborated with more specifically operationalized concepts. The unemployment rate has 6 different operational definitions that can be used in different ways. As scientific concepts evolve, they often acquire alternative operational definitions. For example, how the term unemployment has 6 different operational definitions. Many of psychology's important theoretical constructs are operationalized and conceptualized in more than one way. The case of Pluto's operational definition being updated. In this case, one group of astronomers prefers to stress the geologic composition of astronomical bodies. Another group likes to emphasize their dynamical properties, for example, their orbits and gravitational effects. The operational definitions of the former group include Pluto as a planet, but the operational definitions of the latter group exclude Pluto. Section 3.2. Operational definitions in psychology. The pre-existing bias problem in psychology. The problem is this. People do not come to the study of geology with emotionally held beliefs about the nature of rocks. The situation in psychology is very different. We all have intuitive theories of personality and human behavior because we have been, quote-unquote, explaining behavior to ourselves all our lives. All our personal psychological theories contain theoretical concepts, e.g. smart, aggressive, anxiety. One of the greatest sources of misunderstanding and one of the biggest impediments to the accurate presentation of psychological findings in the media is the fact that many technical concepts in psychology are designed by words used in everyday language. The layperson seldom realizes that when psychologists use words such as intelligence, anxiety, aggression, and attachment as theoretical constructs, they do not necessarily mean the same thing that the general public does when using these same words. When terms such as intelligence and anxiety are used in psychological theories, their direct or indirect operational definitions determine their correct usage. Similarly, in lay usage, the word depression has come to mean something like, quote-unquote, feeling down in the dumps. By contrast, the technical definition of major depressive disorder takes up over a dozen pages in the Diagnostic and Statistical Manual of Mental Disorders. Such a basic and simple word as, quote, significant means something different to a psychologist than it does to a layperson. In psychological discourse about research, significant means something more specific and technical. It means statistical significance, an assessment of how likely the results would have been obtained purely on the basis of chance. Operationism is not unique to psychology. It is characteristic of all sciences. Parsimony. The principle of parsimony dictates that when two theories have the same explanatory power, the simpler theory, the one involving fewer concepts and conceptual relationships, is preferred. The reason is that the theory with fewer conceptual relationships will likely be more falsifiable of the two in future tests. Chapter 3 summary again. Operational definitions are definitions of concepts stated in terms of observable operations that can be measured. One of the main ways that we ensure that theories are falsifiable is by making certain that the key concepts and theories have operational definitions stated in terms of well-replicated behavioral observations. Operationally defined concepts make scientific knowledge publicly verifiable. Such definitions are in the public domain so that the theoretical concepts that they define are testable by all, unlike intuitive, non-empirical definitions that are the special possession of particular individuals and not open to testing by everyone. Because psychology employs terms from common discourse, such as intelligence and anxiety, and because many people have pre-existing notions about what these terms mean, the necessity of operationally defining these terms is often not recognized. Psychology is like all other sciences in requiring operational definitions of its terms. However, people often demand answers to essentialist questions about the absolute underlying nature of a concept of psychology that they do not demand of other sciences. No science provides such answers to ultimate questions. Instead, psychology, like other sciences, seeks continually to refine its operational definitions so that the concepts and theories more accurately reflect the way the world actually is.